All right, so sum and difference formulas. Find sine of 5 pi 12ths. I guess, so the first thing I'll do here is just try to break this up. If you look on the unit circle, we know this is not a possibility on the unit circle, don't we? So this is how we're supposed to know to use this rule. So I'm just going to start trying to break this up and see if I can get pieces that show up on the unit circle. So I tried different values, but the two I think I came up with are 3 pi 12ths plus 2 pi 12ths. I mean, I know this works. If I add these two fractions together, I get this one back. But the question is, do these values show up on the unit circle? And they do, don't they? What is this one? So alpha is equal to pi fourths. And we know the cosine and sine values of pi fourths are square root 2 over 2, right? Comma square root 2 over 2, isn't that right? And then what about this beta value? We'll love to draw beta. Does this value show up? What does this show up as? And pi 6 shows, so we know that beta is pi 6, and we know that the cosine value, isn't it square root 3 over 2? And the sine value is 1/2, is that right? So we took something that's not on the unit circle, and we found values that are on the unit circle, so we could use this rule. Now what? Now FITBA, right? Fill in the blanks. So sine alpha, square root 2 over 2. Cosine beta, 1/2. Right? This plus sign is this one. Cosine alpha. Do I have this one backwards? Oh, good job. Thank you. Good job. Yeah. Square root 3 over 2. Good job. And then here we have cosine alpha. Cosine alpha is square root 2 over 2, isn't it? And sine beta is this 1/2 here, isn't it? Please remember, when you multiply square root 2 times square root 3 is square root 6 over 4, right? 2 times 2. Square root 2 times 1 is square root 2. 2 times 2 is 4. So you can clean this up a lot of ways. You can factor out the 1/4 if you want to. Or if you'd rather, you can just add these two together like this and put them both over 4. Can we agree that these are not easily simplifiable? Is that all right? Good? Let's try one that's this. So this was a sum. Let's try a difference. So here's this problem. Here's sine of pi 12ths. Again, we look on the unit circle. It doesn't show up anywhere, does it, Brandon? So now we're going to try to look at this differently and ask ourselves if we can come up with it. What we learned from the other problem should be helpful, because what I got was 3 pi 12ths minus 2 pi 12ths. If we subtract those, we get pi 12ths, don't we? So that should work. And what's the rule? So now we have sine of alpha minus beta is equal to right? Sine alpha cosine beta. And then what? Minus, keep talking, cosine alpha sine beta. We already know these values. We know this turns out to be pi fourths, doesn't it? And that's alpha. You don't have to actually write all these notes in like this if you don't want to. I just do it so I don't screw this up. And I almost screwed it up anyway, didn't I, Mr. Murray? Right? And then the other one was pi 6th. And pi 6 is square root 3 over 2, comma 1/2. Isn't that right? So sine alpha is square root 2 over 2. Cosine beta is square root 3 over 2. this negative sign right here is this negative sign. We get cosine alpha is square root 2 over 2. Sine beta is still 1/2. Now what? Say it again? Yeah. I'm just going to leave it like this because it looks a little bit simpler. Is that okay? This is not out of the question for me. This makes some sense, doesn't it? Why does this make some sense? Why is this a possibility? Tell me something about what kind of number you're going to get. If you take the square root of 6 minus the square root of 2, what kind of number will you get back? Won't you get a positive number back? Over a positive number would be a positive number, won't it? And what quadrant is pi 12 in? It's kind of a good test of reasonableness to use sometimes.